In today's lesson, we'll be investigating the properties of quadrilaterals. If you've forgotten, a quadrilateral is a four-sided figure. You should be already familiar with these quadrilaterals: parallelogram, rhombus, rectangle, square, trapezoid, and kite. They all have different properties, however, and you should go over these when you have some time. The key concepts for today have been summarized in this box. I'm going to demonstrate these concepts to you with some diagrams. In our first example, you should recognize this shape as a rectangle. A rectangle, however, is also considered a parallelogram. Why is it considered a parallelogram? Well, opposite sides are parallel. I'm going to draw in the diagonals for this rectangle. That would be one diagonal, and that would be the other diagonal. The diagonals of a rectangle bisect each other, which means this length is the same as this length, and that length is the same as that length. In our second diagram, we have a rhombus. However, a rhombus is also considered a quadrilateral because it has four sides. Now, when you join the midpoints of adjacent sides of any quadrilateral, it will form a parallelogram. So let's find the midpoints first. That would be the midpoint of that side. That would be the midpoint of that side, and so on and so forth. What we're going to do now is connect these midpoints, and you should get a parallelogram, which means that side is parallel to this side, and this side is parallel to the opposite side. In this last example, you should recognize this figure as a trapezoid. I want to draw in the midpoints of the non-parallel sides. So that's the midpoint over there, and that is the midpoint over there. If we connect these midpoints, it is said that this line segment is parallel to the other parallel sides of the trapezoid. It is also said that the length of this new line segment is equal to the mean of the lengths of the parallel sides. What exactly does that mean? Well, let's draw in some diagrams. I'm going to call this length A. I'm going to call this length B. And I'm going to call this length C. Mathematically, what that means is the distance of C is equal to the mean of A and B. Because there are only two numbers there, that would be A plus B divided by 2. In today's lesson, we'll be verifying the properties of quadrilaterals. You'll be using all of the equations that you've learned so far. So you're going to be using the length equation, the midpoint equation, and the equation for slope, as well as anything else you've learned in previous units. And you should keep in mind that there is more than one way to verify a property of a geometric shape, which means the way you approach a problem will be different than the way your neighbor approaches the problem, or it could be the same. In our first example, we want to verify that the shape created by joining the midpoints of a quadrilateral with vertices A, B, C, and D is a parallelogram. We already know the midpoint equation, and we know that a parallelogram is a figure where opposite sides are parallel, such as a square, a rectangle, a rhombus. Before doing anything, I would suggest you to do a rough sketch of this situation if you have enough information. And we do happen to have enough information. I'm going to plot my points and I'm going to label them. So let's plot point A. Okay, that is point A. Let's plot point B. Now let's plot point C. And last but not least, let's plot point D. If you connect these coordinates, you'll see that it creates a very strange looking quadrilateral, but it would still be considered a quadrilateral since it has 4 sides. Next, I'm going to roughly draw in the midpoints of each of these line segments, and I'm going to connect to them. I'm also going to label these midpoints so that it's easier to identify them. That's E, F, G, H. At the end of the day, we want to verify if this shape is a parallelogram. So we want to see if this side is parallel to that side and if these sides are parallel as well. Next, I'm going to outline a strategy for how one would approach this situation. Again, it's important to remember that there are many ways of approaching these questions. I am just showing you how I would do it. So the very first step would be to find the midpoints. So find midpoints E, F, G, H with the midpoint equation. Once you have the midpoints, you can find the slopes of each side of this inner quadrilateral that we just drew. Let's write down our next step. I'm going to write find slopes of line segment EF, line segment HG, line segment HE, and line segment GF. Once we calculate the slopes, we have to interpret these slopes. So we're going to compare the slopes of opposite sides. I'm going to write that down. If the slope of EF is equal to the slope of HG, therefore these sides are parallel. Now I'm going to do the same thing with the other sides. So if slope of HE is equal to the slope of GF, therefore these sides are parallel as well. Now, if opposite sides are parallel, that means it's a parallelogram. So let's write one final statement for that. If opposite sides are parallel, therefore it's a parallelogram. Again, I haven't done the math for this question. I've just outlined a strategy. You can go ahead and do those calculations on your own. In our second example, we want to verify that the diagonals of rectangle ABCD bisect each other. The vertices of the rectangle are given. Before we do anything, let's sketch a diagram if we've been given enough information. And it looks like we have, since we have the coordinates of the vertices of this rectangle. I'm going to plot point A, just somewhere over here. Next, I'm going to plot point B. just somewhere over here. Next, I'm going to plot point C, which is somewhere over there. And last but not least, I'm going to plot point D, which is right over here. Once we've plot our coordinates, let's connect the dots. And this should be a rectangle, since it was described as a rectangle in the question. We want to figure out if the diagonals of this rectangle bisect each other, which means all of these 4 line segments will have the same length. I'm going to call this point of intersection E. As I've said multiple times, there are different ways different students can approach this question. I'm going to show you how I would approach this, but you can do something completely different. So the very first step is to find the point of intersection in the middle of this rectangle. And I'm going to use a midpoint equation. So I'm going to say find midpoint E with points D, B, and the midpoint equation. You could have found midpoint E using points C and A. Afterwards, we want to compare the lengths of line segment D and E and line segment E and B. We can do that using the length equation. So let's write that down. Find length of line segment D and E and line segment B and E with length equation and points D, E, and B, which we all have. I'm going to repeat this step for the other points. I'm going to write find length of line segments C and E and line segment A and E with the length equation. You can also call it the distance equation if you want. And points C, E, and A. Now that we have the lengths or distances of all of these line segments, we can compare them. If all of these distances or lengths are the same, therefore these diagonals bisect each other. So let's write a statement for that. If lengths are all equal, therefore diagonals bisect each other. And there you have one strategy of solving this question. There are different ways of approaching this question. Another way could have been figuring out the equation of lines and finding their point of intersection. That would have been a little bit longer, but you could have taken that route as well. In our third example, we want to verify the quadrilateral PQRS is a kite. We're given the vertices of the kite PQRS. Since we've been given the coordinates of the vertices of this kite, let's go ahead and do a rough sketch with this Cartesian plane. I'm going to start with point P, which is 1, 4. Next, I'm going to write point Q, which is 3, 4. Next, I'm going to do point R, which is 5, 0. And last but not least, I'm going to draw in point S, which is 1, 2. I'm going to go ahead and connect these dots. As you can see, you have a quadrilateral which looks like a kite, but we have to verify its properties. Remember, adjacent sides in a kite are equal. So these two sides should be equal, and these two sides should be equal as well. Let's formulate a strategy for ourselves on the side. I'm going to find the lengths or distances of all of these line segments. So line segment PQ, line segment QR, line segment RS, and line segment SP. And I'm going to do that with the length or distance equation. And all of the points which are provided for us. P, Q, R, S. Once we have the lengths of all of the side lengths of this kite, we need to compare the values. So let's write a step for that. I'm going to need a little bit more space. If lengths of line segment SP and PQ are equal, and lengths of line segment QR and line segment SP are equal, therefore the figure is a kite, because remember, adjacent sides have to have the same length. And that is just one way that you can approach this question. In the second part of example 3, we want to verify that the diagonals of this kite intersect at 90 degrees. Before we do anything, let's take this information and do a rough sketch. It's going to look exactly identical to the previous diagram. So let's start with S. S is over here. P is right above it. Q is right beside it. And R is down over here. And I'm going to connect the dots, and that will create a figure which looks like a kite. We want to verify that the diagonals of a kite meet at a 90-degree angle. Let's start formulating our strategy. I'm going to zoom out to create a little bit more space for myself. In a very first step, I want to find the slope of PR and the slope of SQ with the points we've been given. So P, Q, R, S, and the slope equation. Once we figure out the slopes of these diagonals, we need to interpret them. So let's write a step for that. If the slope of PR and SQ are negative reciprocals, therefore the diagonals intersect at 90 degrees. So it is really important that you remember that lines which intersect each other perpendicularly or at a 90-degree angle have slopes which are negative reciprocals. You'll see this repeating again and again. And there you have one way of approaching this question.